All right, guys, here we go. So basically, after we talked about the forces of fault yesterday, one thing we didn't talk about were basically the earthquakes themselves, and then the seismic waves that they actually create. So the best way to think about a seismic wave is think about throwing a pebble into a pond, and you get a bunch of ripples, right? Now, I want you to talk about those ripples over time. If you're right there by the ripple, or right there where the rock goes in, what can you tell me about the size of the ripples?
It's going to be big.
Yeah, we get really intense up front, and as you move away, what happens to that intensity? It expands, so therefore my intensity actually decreases, all right? You get the same thing with an earthquake. The farther you are away from the epicenter, then the less intense the waves are going to be. Okay, they're going to lose their momentum, they're going to lose their power, their energy as that distance increases. So it's basically the same concept. Now, one of the things that's kind of important for us to differentiate between is the epicenter versus the focus. Our focus is the actual location within the Earth. So you can see that right here. See how that's very deep inside the Earth? That's your focus. So it's the location of the earthquake within the Earth. But a lot of times what we're more concerned about is the epicenter. And the epicenter is, if you can imagine taking this point and really putting it on top of the surface, that would be your epicenter. Alright, so the epicenter is the location directly above the earthquake, and it's on the Earth's surface. So our focus is inside the Earth. The epicenter is on the Earth. That's basically directly above it. And when these earthquakes occur, they occur with three different types of waves that are created. And these three types of waves are labeled right here: primary, secondary, and surface waves. With your primary waves, we often refer to these as P waves. Secondary waves are S waves. And unfortunately, there's no abbreviation for surface wave. What does primary and secondary mean? Primary meaning what?
First.
The first. Secondary meaning second. All right, so which one do you think is the fastest? Primary, okay? So keep in mind that not all seismic waves travel at the same speed. Okay, so primary waves are definitely the fastest waves. And they move in the same direction as the wave. Okay, and then this is going to be kind of weird, so I'm going to hopefully have some models out here for you guys. When I say they move in the same direction of the wave, so our wave is going to be moving in this direction. What happens with the P wave, you can see how it shoves the point back and forth. That's moving in the same direction, right? The point's moving left and right with the direction of the waves. That's your primary waves. They move the same direction as the wave. Your secondary waves are not as fast as primary, but they're not the slowest. So they're kind of your medium speed. And they move perpendicular to the wave. So if I'm talking about my diagram right here, if my wave is horizontal, which way do you think the secondary wave is going to move? It's going to move up and down. So you can see how that point then moves up and down. So that's your secondary wave. And then your surface waves, well, they're just no fun. Surface waves move side to side. And they're as close. They actually, a lot of times your surface waves will not go very far. These tend to lose their energy very quickly. So now I want you to put yourself in the middle of an earthquake. Here's the problem with an earthquake. It's not so much that you're moving up and down. It's not the problem that you're moving forward and back. Not so much the problem moving side to side. The problem is that you're doing all of these simultaneously. And that's why we have so many buildings that are easily destroyed during the earthquakes, because they simply cannot take that stress. Right? When we think about some of the older cities in California, they're all brick. Okay, a lot of the homes are still old brick homes. Brick and the mortar that they use in brick doesn't really give way. Okay, cement is not a good bending material. So when earthquakes hit, it breaks very easy, and then the buildings collapse. And so one of the things that they're doing in California right now are all the high rises, your skyscraper buildings, all of them are being built with new types of foundation. You guys seen those before? You know, what's the foundation built out of? It's not so much the fact that it's metal, but it's a special type of artificial shape. They're on springs. So you can imagine this big, huge building sitting on a series of springs. And the springs absorb some of that upward motion, the side-to-side motion. It actually allows the whole building to sway with the earthquake. Now you'll have damage, but you're not going to have catastrophic damage. That's one of the things that we're doing differently today. All right, and that's it. That's the end of our notes. So it's going to be fast.
Girls are